Okay, I'm back, and today we're going to talk about fronts. Now, tomorrow we'll get into more specifics about cold fronts, warm fronts, stationary fronts. Today I just want to talk about general characteristics, what you need to know about a front in general. So we're going to start right up here with just basic definition. A front is called a front because it's the front of an air mass, the leading edge of an air mass. So if you picture an air mass as a bubble, we said last time high pressure's in the middle, low pressure's at the edge, and so the front is the leading edge of that air mass as it moves. So we don't usually draw the whole air mass, we just picture it by looking at that front. So what exactly is happening along the front though? So the front, if we look at it from the side view, which is what we're going to see over here, is the front is always slanted, so the less dense air slants up over the cold air, and we can see that really well in the picture over here. So this is supposed to be like we'll say a warm front. Okay, actually, you know what, this has to be a cold front. I'll show you why in a second. So from a side view, the warm air, hang on, I screwed that all up. This will make more sense later, sorry about that. Try again, take number 2. In any front, the less dense warm air goes up and over the more dense cold air, and it creates a slanted surface. As the less dense air goes up, it gets cold, forms clouds, maybe even some rain, and this all happens just in front of the front because it's slanting up and over. Now, some fronts are steeper and some are more gradual, but it's always slanted. And the less dense air always goes up and over the more dense air. All right. So now we're on a roll. Now I'm doing it right. Along a front, there is a temperature difference. If it's a cold front, then it's colder back here than it is up here. If it's a warm front, it's warmer here than it is there. I think you guys already understand this, but along a stationary front, the warm air is trying to go that way, the cold air is trying to go that way, and it's a stationary front. The difference in temperature is what makes it more dense or less dense. Because remember, the density makes it go up. There's also a pressure change right here. So, remember, in an air mass, low pressure is found at the edges, high pressure is found in the middle. So, let's just say this is you, and there's a front headed towards you. You're in high pressure air, so it's nice and sunny. As the front approaches, the pressure gets lower and lower and lower and lower until you get to the front. That's when the pressure is the lowest. And then once the front goes by you, it's going to get a little higher and higher and higher until you hit a high pressure center, and it goes back and forth as you go into an air mass and then back out of it. But again, the pressure is the lowest right along the front. So as it says right here, as the front approaches, the pressure drops. After it passes, the pressure goes back up. Air rises at a front. Again, because of this slant, the less dense air goes up, the more dense air goes, over here the less dense air is going up, same as here. If it's a steep slant, it goes up fast. If it's a gradual slope, it's going to go up slow, and you're going to see tomorrow why that makes a difference. Actually, you should already know that because we talked about clouds. And when the air goes up fast, what kind of clouds are we going to get? Puffy ones. When it goes up slow, what kind of clouds are we going to get? Stratiform clouds. Okay. Oh, hey, I'm getting ahead of myself. When you have a steep slope, it goes up fast and you get puffy clouds. When you have a gradual slope, it goes up slow and you get stratus clouds. Last but not least, precipitation. If I have a steep slope to my front and the air is going up fast, all that moisture, let's go back to this picture, all the moisture gets trapped in a narrow area. So all that moisture is focused right in. So when it forms drops, they're really big drops. They're really cold and they're going to fall really fast. So when it's a steep slope, all that moisture is trapped together into heavy, narrow band of rain. In a gradual slope, all this moisture is spread out. So the rain is going to be spread out. The droplets won't be as big, and so you get light rain, and it's spread over a wider area because it's all spread out. So when you have a gradual slope, you have light rain, and there's a wide band of it over a nice wide area. So those are some general ideas about fronts. Tomorrow I'll get back with you and we'll talk about specific types of fronts and why you get thunderstorms along some and why you get light rain along some and what types of clouds you get, and we'll fill in all the details.